All right, fifth grade. Well, we're finishing up chapter 14 today. This is really our last video out of the Big Ideas curriculum. We'll have to see kind of where we're at come the end of the school year and see if we're going to do some extra things beyond this. But, well, yeah, so we're finishing up chapter 14 today, and it focuses on quadrilaterals. And the first thing I want you to look at here is this Venn diagram. And I would suggest taking a screenshot or copying this down or something while we have this here. But I'm going to talk about this for just a minute or two, but I would suggest at some point while the screen is on this that you take a screenshot or copy it down or do something so you have something like this to look at. The entire box along the outside here represents all quadrilaterals, which is why here we have quadrilaterals. And as we talked about in the previous lesson, a quadrilateral is a four-sided figure. Here we have just a general four-sided figure, no real shape, kind of looks like an arrow or something, but it's a closed figure and it has four sides. Thus, that's what we refer to as just as a general quadrilateral. Everything in this box is a quadrilateral, which means everything in this box is a closed four-sided figure. This one here that's kind of off to it by itself is a trapezoid. And we talked about trapezoids having exactly one set of parallel sides. You can see that the bottom and the top are parallel. If they continued on forever, they would never touch. Of course, once again, we're assuming that Mr. Swack's drawings are all perfect and square and everything else, but we can use our imagination a little bit. Now, a large part of this Venn diagram within quadrilaterals is parallelograms. Now, let me go back to trapezoids first. Trapezoids fit under the idea of quadrilaterals, but you'll notice that there is no crossover between trapezoids and parallelograms, because a parallelogram has two sets of parallel sides, meaning the left and the right side are parallel, the top and the bottom are parallel. Trapezoid does not fit into that because there's only one set of parallel sides. So a trapezoid, even though it's in the whole quadrilateral box, it's kind of off here by itself. A large part of the quadrilateral world are parallelograms, like we said. A general parallelogram essentially looks like this, with the left and the right being both congruent and parallel, the top and the bottom being both congruent and parallel. Now, within the world of parallelograms, which are within the entire world of quadrilaterals, we have rectangles. A rectangle is a special type of parallelogram. Yes, it fits the definition of parallelogram, where the left and the right are congruent and parallel. The top and the bottom are congruent and parallel. But a rectangle has four right angles. I didn't put those in there, but we can. Remember, those are the perfect L's. Okay? And fitting within the idea of a rectangle, you'll see a connection here is a square, because it has four right angles, even though all four sides are congruent. Not all rectangles have to have four congruent sides, but it can. But if it is, it's also referred to as a square. A square is a special type of rectangle. Now, also within parallelograms, a larger group is rhombus. A rhombus has four congruent sides. A rhombus does not have to have four right angles, but it can. The only rule for a rhombus is that it has to have four congruent sides. A square has four congruent sides. So a square is a special type of rhombus where there are four right angles. Just like a square is a special type of rectangle in which all four sides are congruent. So a square, not only is it a square, it's a rhombus, it's a rectangle, and it's part of even this bigger group of parallelograms and even a bigger group of the quadrilaterals. So we're going to be using this idea of our Venn diagram to look at some different questions, and basically we're going to have to determine whether these questions are true and false, and they're going to have to do with quadrilaterals. And so you're going to have to put something like this Venn diagram in your notes to help you answer these questions. And so we've got 5 examples, and the one set of directions we need to focus on today is tell whether the statement is true or false. Okay? So this says tell whether the statement is true or false. Well, the first one says some trapezoids are quadrilaterals. Really, that's not a very good question. I'm going to get this word some out of there because trapezoids are quadrilaterals. So yes, that's really, that is a true statement that trapezoids are, in fact, you know what? Let's go ahead and leave that. And I apologize for this confusion, but let's just go ahead and leave that. Some trapezoids are quadrilaterals. Well, if I go over to my Venn diagram here, and I see trapezoids, and I see the entire circle of trapezoids are within quadrilaterals, that tells me that all trapezoids are quadrilaterals, not just some, all of them. So you could make an argument when it says some trapezoids are quadrilaterals. That's true, because some of them are, but really, they all are. So this statement in and of itself, I'd say, is false. But I'm going to be the first to admit that's not a great question, because really they all are. And if I wanted to change this to all, or just like I did, get rid of this first word altogether and say trapezoids are quadrilaterals, then it would be true. But the idea that only some of them are is false, because all trapezoids are quadrilaterals. Now, here it says all squares are rhombuses. Well, if I look here, I see a square, and that all the square, it fits in the rhombus circle. And that makes sense, because a square, all 4 sides are congruent. They're all the same length, and that is the definition of a rhombus. A rhombus has 4 congruent sides. So yes, it is most definitely true that all squares are rhombuses. That is most definitely true. A trapezoid is a parallelogram. Well, if I come here and I look at my Venn diagram, I see the trapezoids are all here, out here by itself. And I already differentiated with what parallelograms are, because parallelograms have 2 sets of parallel sides, where the left and the right are parallel, the bottom and the top are parallel, but a trapezoid only has 1 set of parallel sides. So for this to say that a trapezoid is a parallelogram, that is most definitely false, because a trapezoid only has 1 set of parallel sides, and a parallelogram has 2. All squares and rectangles are parallelograms. All squares and rectangles are parallelograms. Well, if I look here, I have my big box of quadrilaterals. I have my large group within quadrilaterals of parallelograms. And it's saying all squares and rectangles are parallelograms. Well, absolutely. Because a rectangle, the bottom and the top are parallel with each other. The right and the left are parallel with each other. And in a square, the right and the left are parallel with each other, and the top and the bottom are parallel with each other. So a square has 2 sets of parallel sides. A rectangle has 2 sets of parallel sides. Thus, they are both parallelograms. So when I look at number 4, and it says all squares and rectangles are parallelograms, that is absolutely 100% true. Number 5, all rhombuses are rectangles. All rhombuses are rectangles. Well, when I look here, and I look at my quadrilaterals, and I go into parallelograms, and I look at rhombuses and rectangles, I see that there is some overlap between what a rhombus is and what a rectangle is. But the overlap is only with a square. Because a square, it's a rhombus because it has 4 congruent sides. It's also a rectangle because the left and the right are parallel and congruent. The bottom and the top are parallel and congruent. And it has 4 right angles. Okay? And so that would be the definition of that. So it's asking all rhombuses are rectangles. Well, it looks like some rhombuses are rectangles if they're squares. But you certainly do not have to have a rhombus that has 4 congruent sides that has 4 right angles. So it's not fully overlapped. This would be the example of a rhombus, but that is not a rectangle. So when we look at number 5 that says all rhombuses are rectangles, that's not true. Only some rhombuses are rectangles, and that would be if it qualified as a square. All right, we'll talk to you later, 5th grade. This is lesson 14.3. Talk to you later. Bye.